The normal distribution is a continuous probability distribution, and it's completely symmetrical. So that means that if I consider the point right in the middle, or I divide it like this, it looks exactly the same on the left-hand side of that line as on the right-hand side of the line. So that means I know that 50% of my values are to the left and 50% are to the right of that line. I also know that if I put a line somewhere else, so for example here, that if the probability that my value is greater than whatever x is here, let's imagine the probability is 0.3. I also know that if I had exactly the same line but on the other side, so let's imagine down here this was a distance of k. If I had a distance of k again to another line, such as this one, that the probability, because of the symmetrical nature, the probability of being below that value would also be 0.3. And that's because of the symmetry between this and this. It also means, therefore, that the probability of being below this value of x, which is 0.7, will equal the probability of being above this line, 0.7. The symmetry exists everywhere. And what that means is we can now start calculating quite a lot of different probabilities with only a few points. For example, knowing that my mean is here and the probability is 50%, and the probability of being above my green line, my x here, is 0.3, I also know the probability of being between these two lines is 0.2. And I know the probability of being between these two lines is 0.2. And I can continue to use the symmetry of the normal distribution to find a large number of probabilities with very few points. What I would generally use is 1 point, a reflection, and the middle point. If I'm given a second point, then I have even more that I can manage. This is really useful as well when we consider the approximation of distribution with the normal curve. So if this is our center line, and therefore our mean, which is always in the middle, and the mean, median, and mode are all in the same place for the normal distribution, we know that 50% of data is above and 50% of data is below. Or the probability of a point of data being above is 50%, and the probability of a point of data being below is also 50%. Now we also know by our approximations that plus or minus 1 standard deviation, which we might be able to place here, our data is, there is 68% of data between these 2 points. So this is the mean minus 1 standard deviation, and this is the mean plus 1 standard deviation. Now, knowing this, we can therefore calculate that there must be 34% here and 34% here. We also know, because of our approximation, that 2 standard deviations from the mean, which might be there and there is 95% of data. So therefore we know that there's 47.5% and 47.5%, because that divides the 95 in 2. We can also therefore work out this area, because 47.5% minus the 34% will give us 13.5%. and therefore it's the same here. And so on, and so on, and so on. So it ends up becoming quite possible for us to make some approximations based on our already known approximations from the standard normal curve and be able to work out the probability that data falls within any of these different vertical sticks, all 7 of them, and also beyond them as well. It's worth keeping this in mind, and it's also worth having something like this that lists all of the probabilities in your bound reference. And finally, we can write a few equations if we consider the standard normal curve. And you'll notice I've got Z written here. For example, I could say, if I consider the probability that a variable is larger than a Z-score of 2, so the probability that Z is greater than 2, that equals the probability that Z is on this side because of my symmetry. So it equals the probability that Z is less than -2. I could also consider in a similar way the probability that Z is between 0 and 2 equals the probability that it's between -2 and 0. And so on. So looking at the symmetry of the normal distribution, specifically with the standard normal curve or the standard variable, we can start seeing the types of equations we can make which use symmetry to help us solve problems. So if I know, for example, that there's 20% of data above this point, I know there's 20% of data below this point, and so on and so on. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.